This is from work from some of my team, and I'm going to go through a little bit quickly at the beginning because I want to make sure we stay on time too. But I've talked about this before, but basically our idea is that what we know now from our decade and a half of work with kids with this disorder and some of the other folks that have been doing work is that we know that there are a range of cognitive impairments that these kids experience, and they of course vary within the child, within different domains, and of course across children dramatically. But those create real difficulties for them. But we found as part of our clinical assessments and our clinical interactions with the folks, particularly the things that Kathy and Ingrid do, and I am sort of involved in, is that we find that there are some kids who, despite their limited cognitive capabilities, are really outperforming their expectations and are doing beautifully, and others who have higher levels of intellectual capabilities and are not doing very well at all. And we talk about these as copers, who are the ones who have low levels of anxiety and high levels of adaptive functioning. And the strugglers are the ones with the opposite pattern. And that seems to be a potential moderator of what the outcomes are going to be. And that's really what we're trying to focus on. So it's a hypothesis. We don't know this for sure, but our hypothesis is that those kids who are the strugglers might be at more stress and at higher psychiatric risk. But this is not a unfixable thing. These are actually, none of this is easy, but these are tractable targets that can be addressed in standard clinical approaches, and that's what we really now try to do as part of this 22Q Healthy Minds Clinic that some of you have seen and mentioned on our website. So I'm going to cut this a little bit shorter than I usually do to keep moving, but the idea is basically independent of one's intellectual capabilities. This is something called the Optimum Stimulation curve, and you can think about this as stress or stimulation on this axis and amount of activity on the other. So if you're not stimulated, and sometimes stress is a good thing, you have to be a little stressed to be prepared. We wouldn't have got ready if we weren't a little bit stressed. If you're going on a trip, you have to get a little bit of stress to get yourself ready. There's the fight or flight mechanism, which in short doses is supposed to get you ready to do things that are important to you, but you don't want this on an extended period of time. So stress is not necessarily always a bad thing. And so as we get a bit more stressed, a bit more stimulated, we become more alert, we become more engaged, and there's this moment where there's sort of the optimum stimulation. What you're capable of doing perfectly matches what you're being asked to do, and you feel like you're firing on all cylinders, and it makes you feel good. It makes you feel good emotionally and cognitively, and your biology is in good shape. If you get pushed over the edge of that curve, you know, you're doing beautifully at work and somebody calls you up suddenly and says, you were supposed to give me that report yesterday, I need it now, and you go, okay, I can handle it, but you know, you feel a bit stressed. Your body will actually change, your biology will actually change. And then if the school nurse calls you up right in that moment and says, your kid's in the school nurse's office, you better come and get them, you're probably screaming and swearing and tearing your hair out at that point. You really are under stress at that point, and now you can't function so well. And so that's sort of biologically appropriate, but it's not something we want to do on a chronic basis. And so the point is that kids who are operating over here regularly are actually not being able to function to the best of their abilities. And the question is, how do we move them back this way? That's what we're trying to understand. So one of the things that we have found, this is Kathy's work we published recently, is that we usually in all of my slides, the pink dots are the kids with 22Q and the blues are ones who are typical. We got them back to front on this one. But adaptive functioning is something really you can think of as everyday real-world problem solving. Be able to get dressed, brush your teeth, ride a bus, get to school, make change, all those different kind of things, not what IQ tests. But usually IQ is highly correlated with adaptive functioning. So in typically developing children, you see in the pink dot, the higher IQ, the better your adaptive functioning is. In the kids with 22Q, and this is 99, and we're now over almost 150, we see there's no relationship at all. And this is a very unusual finding, because even in other developmental disorders, we see that correlation. So the question for us is, what is driving the ability to function well in the real world? And what we found is a very strong negative correlation between anxiety and adaptive function. So the higher the anxiety is, the lower the adaptive functioning is, and vice versa. And so these are the kids that we call the strugglers, and these are the kids that we call the copers. And the question is, can you move them around, okay? And so, and in fact, you can move them around, and it takes basically straightforward, involved, standard clinical approaches to do that. But our interest in the lab was, well, if you have kids who are outperforming their intellectual capabilities or underperforming their intellectual capabilities, That's what we call a trait measure, basically, when we measure anxiety or adaptive function. That's what you're like generally. The question then is, what about in the moment? So the video you just saw, that young man was not able to obviously function because he was being teased and he was very upset and he was very stressed. So that sort of shuts down your cognitive capabilities. But what if you're in a calm place? Can you function under those circumstances? So we've been asking the question of how does the change in these emotional states change your cognitive functioning, because that will give us an idea of what kind of interventions might be possible. So these are some great people in my lab. Some of them are here today. Abby's here and Josh is here and Lang moved on recently. But we have lots of evidence of things like the ability to control one's attention. I don't have time to unpack that today. You've probably heard me talk about it before. But what we're interested in doing now is looking at how does your cognitive capability get changed as a function of your emotional state, and we try to manipulate your emotional state by the stimuli that you're looking at. So in this task, it's like many of our other tasks. The children are asked to look at a screen, which is black, and there's a cross in the middle, and they look at that cross, and then we put up two faces. And we don't tell them anything specifically about the faces. We simply say, we're going to put these two faces up on the screen, and one of them is neutral, and another one is, anybody know what that one is? Angry, unhappy. It's a standardized face, or it could be happy, right? And so you get one of these pairings, and then you look at this for half a second, and then this little dot, the star comes up, and you simply have to press a button to detect that. And what is known is that people who are very anxious, typically speaking, people who are very anxious will look towards the worrying stimuli. There's a sort of, alerting response. Gee, that's something I'm a bit scared of. I should pay attention to that thing. And so what we wanted to know was, how does this change functioning? Now, for us, we typically bring in kids, I'm using the word typically two different ways. We usually bring in kids who have 22q deletion, or they're typically developing kids who don't have any other disorder, and sometimes bring in kids with other different kinds of disorders. So here we were comparing kids who were typically developing and kids with 22q, but that's not the distinction. It's really not very interesting for us to compare one with the other. We wanted to know what happened if you had lots of anxiety in your functioning. So it wasn't matter what your diagnostic label is, it's how well you could do that. Or how well those things related to one another, put it that way. So without having time to explain exactly what's going on with this analysis, we throw the measures of each child's adaptive functioning and anxiety levels into something called a clustering algorithm. We ask it to tell us what are the real groupings here, not typical versus 22q, but sort of who collects together in different ways. And what we find is that there are these two big clusters. The green one is almost completely comprised of blue dots, which is typically developing kids. And the purple one is completely comprised, 100% of kids with 22q. And this cluster is basically kids who have high levels of anxiety and low levels of adaptive functioning. So these were the kids when they walked through the door who were the copers, the strugglers rather, and these were the copers. And you see there are some kids with 22q in here, so it's not just that. So now if we ask what happens when we show them these faces, the angry face versus the neutral face, and the happy face versus the neutral face, who looks at what? This is Abby Popa's graduate study work that she's doing right now. And what you can see here is that the copers who are in green look more, if we average the looking over the whole experiment, they look more at the angry face than the neutral face, because it makes sense to look at something that's empty thread, at least in the beginning. And so do the kids with the strugglers, who are all kids with 22q, as it turns out. The effect is a little bit muted here. But when you looking at the happy faces, the copers always look much more at the happy face than do the strugglers. So there's a difference here in the way that they're processing different positive and negative emotions. And again, I don't want to spend a lot of time digging into the very highly specific details of our interpretations here, but what it tells us is that the people who are more anxious and less competent in the world are responding differently to the stimuli that are emotional that they're getting, and it's changing the way that they're controlling their cognition. And similarly, if we ask the question of not where they're looking, but what is their arousal level, and you can measure arousal by what happens with the pupils in the eyes. When the pupils dilate, it's thought to be a measure of arousal increasing, and when the pupils constrict, it's thought to be a measure of it going down. And so what happens here, this is looking at the angry faces, and so we're really interested in what happens over the time course of the experiment, because you're seeing the same faces again and again and again. So it makes sense to look at somebody who's angry, but if you keep seeing the angry face again and again and again and nothing bad happens, you should eventually just say, well, that's empty thread, I don't really care very much about that. So what you see is that at the beginning of the experiment, the copers attend very heavily to the angry face, but by the end, well, this is the amount of arousal. The arousal goes up at the beginning, but then it goes down at the end, okay? And then the kids who are the strugglers, all of whom again have 22q, seem to kind of shut down in the beginning, and then they get more aroused over time. So they're increasingly getting arousal off these things the more time they're seeing them. And when we look at happy, no one really cares about the happy things. It's not terribly arousing. They're kind of nice, but they're not terribly arousing. And so you see that the copers gradually sort of their arousal goes down and down and down, but the strugglers, their arousal keeps going up. So whatever this really means, what it is telling you is that there's a very different response to the emotional environment around them, and it is affecting their cognition in different ways. So I'm rushing through this quickly because the interpretation is sort of important to us in one sense for understanding what it's going to do. But more importantly, it's showing us that there's a really different response, and these are different targets that we want to understand. Okay, so the fact is that by being stressed and being anxious, it's changing your cognition in different ways. And I'll come back to why that's important in a moment. Another experiment we do is part of self-regulation. So being well-regulated is being able to attend to the important things and also inhibit unwanted behaviors, not doing something like hitting somebody or blabbing something out when you're not supposed to do it. So this is the famous whack-a-mole experiment that you've probably seen us talk about before. This is the work that Heather Shapiro did in the lab here. So basically what the kids see is a whole bunch of these funky moles in funny little disguises showing up on the screen. And every so often a vegetable comes up and they're supposed to not respond. So you press a button when you see the mole and whack the mole, and you wait when you see a vegetable, okay? So really we're interested in what happens when we see one mole or 3 moles in a row or 5 moles in a row, okay? And what we see here, there's a lot of data on here, but I just want to point out the most important things. As a group, there's not a huge difference. One of the things that you see here is that as you see more and more of these moles over time, 1 mole, 2 moles, 3 moles, 4 moles, 5 moles, the kids are slowing down because they're realizing sooner or later they're going to actually have to wait and not press the button. And so you see that the kids who are typical in blue and the ones with 22q in pink are doing this exactly the same way. It shows that they're understanding the task exactly the same as one another. But when it actually comes to withholding the response, when it actually is supposed to be not pressed, you see that the more moles you've seen, the more likely it is that you're going to have to withhold the response, the more accurate the typical developing kids get. Now, everybody's doing quite well. They're doing about 70% accuracy, but the more warning, the more information is not helping the kids with 22q as a group do a whole lot better. It's actually not very important to look at the group, because what we always find is there are some kids who do well and some kids who don't do quite so well. So the blue line here is with age, and you would expect this task to get better with age. And you can see that the typical kids and the blue dots who they represent are getting better with age. But notice there are many, many kids with 22q who are doing just as well at the same age as the typically developing kids are. So they're doing just fine on this task. But there is a small group down here. These are not longitudinal data. We haven't followed them over time. But there are some teenagers who really are not able to withhold this response. And so you can see that it's really this group who's sort of dropping out. These black lines are the average of the group. The younger typicals, the older typicals, the younger kids with 22q are doing really rather well, and so are the older ones, but there's a few who are not, okay? So this suggests that there's a weakness in some of them, and this is an important skill for certain kinds of, it's an important component of certain kinds of psychiatric disorders. So again, we ask the question, what happens if we change the emotional state of the person in this circumstance? Does it do anything to it? So what we've done is we've done things now, and this is the kind of the future of where we're heading with other kinds of experiments, is we do these same kinds of inhibitory experiments, but this time using the emotional faces. So instead of the moles and the vegetables, we have either a string of angry faces, and then when it comes to a neutral face you have to withhold, or we have a string of happy faces and you have to withhold. Okay, this next slide is very busy, but it's only to show you, these are the data that you saw before, okay? This is what happens when it was just moles and vegetables. And this is now what we did, and we made, instead of moles and vegetables, we made happy or angry faces, and the vegetable would be the no-go. And so basically what you see here is the dotted line is the happy faces. And so if you just look quickly, you see the dotted line is roughly similar to where they were before. So when it's a happy face, you're seeing happy, 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 the performance is rather similar to just the moles and the vegetables. But when we add in the angry faces, which are the solid lines, as you see a bunch of angry faces, you begin to get activated by them, you actually see that performance goes up rather a lot. And that's important because imagine you're walking through the forest and you see a snake and you don't want to step on the snake, or you want to take a picture out there and you line up and go, whoa, snake, I'm not going to go over there and get my picture taken. You want those cognitive breaks to go on, and so this actually enhances things sometimes. But again, if we break out of the group, that you see that when it's angry, you see that the one angry face doesn't do much, but as you start to get to 3 angry faces and then 5, once again you see that some of the kids with 22q are really doing much worse than the typically developing kids because their accuracy is way down here, but that's not really happening when it's happy. So the more negative and aroused and upset they get, the less able they are to control both their attention, what to look at, and withhold their negative responses that they're not supposed to do. And so how does this start to relate to psychiatric diagnoses? Well, really quickly, what we see is we took basically anxiety and anxiety and ADHD diagnoses, and we simply said one is minor, and that's basically white. Pink is sort of low level, and that's sort of in the middle, and then red is high level. And what we looked at from about 74 kids is we had a small group who had neither one of the two, a small group who just came up with ADHD of a fairly serious level. Some had just anxiety to a moderate to a high level, but many of them had both. And so actually what it turns out is that almost all of the kids who had high levels of anxiety got an ADHD diagnosis, not quite so strongly the other way around. So our point really here is that the more hyper-aroused you become and the more emotionally unstable you become in the circumstances, we think that drives your inattentiveness because you become very hyper-vigilant, you become upset, and these are targets for us to be able to adjust how things behave. So if you have an IQ of 75, which many kids with the chromosome 22q11 deletion have, it's not across the board. Sometimes you do great, sometimes you don't do so well. But if you do have an IQ measure of 75, that means your development is 75% of what it's supposed to be. So in some domains, even though you're 12, you're only able to function like a 9-year-old. Okay? That means that it's very hard to function. Imagine taking a typically developing kid and dropping them 2 grades ahead from where they actually currently are. And so the fact that there are high levels of anxiety and high levels of inattentiveness, we think might be relating to those different kinds of things, okay? And so again, I'm going quickly because I want to just sort of put these ideas out there and we can discuss them more. You may also have heard that a very large group of us around the world were funded by the National Institute of Mental Health to start looking at the relationship between these things, primarily the genetic functions and the psychiatric functions. This is the very first paper. It just came out. But I wanted to show you a couple of things. This is the sample. It's actually 1,402 cases of people around the world who'd already been studied. And this is the age distribution. So most of them were young adults or children, and there was a few older ones. And what we see is that anxiety was very common across the entire age range. It's actually only about 2/3 of the rates that you see generally, and there's reasons for that. But it still shows that anxiety is quite high across the whole age group. In this age group, in this sample of 1,400 people, the older ones, schizophrenia had been diagnosed at 41%, which is extremely high. But think about those people. They were born 40-some years ago, 30 to 40 years ago, and they weren't being followed. If you look at exactly the same population of people, the diagnosis of schizophrenia is down at 24%. And so the point being that we now know so much about this and you can get on ahead of the disorder, the diagnosis rate is coming way, 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 way down. And in fact, my colleagues who are studying the conversion rates in young adults are reporting more like 10 or 15%. Now, very often that's because they're sort of jumping on any sign that you see, and Cam is going to talk about this in a moment. Many times they're getting treated with antipsychotics and other things like that, which aren't really necessarily the best things. But you can see that already it's being very effective, okay? These are very busy slides, which I don't want to go through either, but just to say the rates are pretty much consistent with that, except that the anxiety rates are a little higher.